just off the subway up to work. I'm checking in like CNN on the schedule first. Roll call, we all sitting down and stand up. Head into our desks and I grab a banana. Do a get pull, NPM build, 2 terminals. The question is, will the loader controllers reaching out, branching the tree as it grabs through the sea of packages? It's crawling and searching, logs rolling out. Now it's stalling and lurching. It's pretty clear this is severe, and it is plain to see. I can't work, can't pull a main dependency. Real talk. How many times has it been that you roll up on Tuesday and maybe even just came back after lunch and like some open source dependency rolled out, and maybe you're trying to clone a repo that somebody built like last week, and like suddenly it's not building. It's like something has flipped up, something has changed on you, or you're getting an error that somebody else isn't getting on their machine because your operating system is different, or it's conflicting with some C library that you built to fix some other similar problem like 6 months ago. And this is just a massive headache. I want to talk a little bit about packaging today, with the goal being that we contextualize Nix for the cloud native practitioner. Just pull up a little bit of my slides over here. We'll just pop over to different layout. Cool. Yeah. So I'm here chilling in Colorado. My name's Leigh Capili, and I'm a longtime cloud native type person, contributed a good number to Kubernetes and to projects like Flux, like the continuous delivery project, Flux. Not talking about Flux today. I'm talking about Flox. I still don't know how I'm going to deal with this, but Flox is the startup that I'm working with. And because I joined the Flox team, I have a bunch of teammates who know a lot about Nix. So I'm learning Nix, getting a lot more context in it, trying to become not ignorant. And I want to use my context in the cloud native world to maybe try and share a little bit of what I'm learning about Nix and some of the revelations that I'm having, because I think that there's a lot of opportunity for cloud native people to employ Nix in their infrastructure, in their systems. We're going to talk about going from workflow to artifact to runtime today. We're going to spend a lot of time on workflow because I think there's just a lot of cool things that we're building that are very concrete here. But cloud native Nix, let's get into it. Gotta click this. Here we go. Software is complicated, but what we're really trying to do at the end of the day is take assemblies of things and then build some really cool tools, some cool systems, some access to information, right? We're like trying to change the shape of the world. And we get together with people a lot of the time and are like, hey, let's collaborate on some software so we can do something valuable that prints money for shareholders or makes the next like ride sharing app, but for dogs or something like that. And each kind of software project has its own annoying collection of stuff. That stuff comes in a couple of different shapes. It comes in tools. It comes in libraries, right? Like things that other open source developers build because they have a lot more domain knowledge on something like how to calculate elliptic curves or, do some other cryptography stuff or like, I don't know, munge big integers, or even just the standard libraries from all of your programming languages that are really good at recursive descents or walking file paths and sanitizing inputs and stuff, right? Just things that you don't want to mess with. You need libraries for that. I mean, you could put enough libraries together into an opinionated workflow and you call it a framework. And then we have to configure all this stuff. And so there's a little bit of a software project. We got to combine a bunch of things together, but each project has its own annoying collection of stuff, right? And when you have annoying collections of things, it becomes even increasingly annoying to share them with other people. But remember, a lot of software is collaborative. So this is just like a constant pestilence in our life. And then you get into the thing with, what if I want to work on a thing that I was working 8 months ago? And reproducing that annoying collection of stuff on a brand new machine, or even just like reinvigorating it on a machine because you deleted it, or like trying to run CI for something. It's just like these things drift and they break because they're pulling from public sources, and the builds themselves are not structured in a way that is going to last the test of time. So planning for the future is tough. So this is some of the problem space that we're trying to think about with Flox, right? So Flox is a company, but it's also the name of an open source project, right? You can just go to github.com/Flox. That's a GPL v2 licensed open source project written in Rust, and you just clone it. And if you install Flox as well, you can start up the dev shell really easily and just contribute on a real cool Rust project. And we're trying to make it so that your dev environments are reproducible, and not just across time, but that for each of your projects, like they stay relatively contained, and that you can work on all your projects regardless of what platform is in your hand. Right? If you're on an Apple Silicon Mac, that you would have success reproducing the software environment necessary to collaborate on something as somebody who's on that weird Arch Linux framework 13. And that once you get that working, it'll still work 3 years from now, or 5, or even 10 years, which that seems a little bold, but that's the idea. So in order to do this, we have built the open source tool, which is a package manager on top of this other sort of package manager technology called Nix. Nix is really a functional programming language that you can write these input-output expressions in. And those expressions then end up becoming declarations of packages or descriptions of packages. But Nix doesn't work like most package managers. See, most package managers, they're taking these amalgamations of things, and then they're distributing the different kinds of things that you find in a package across the standard hierarchy folders that you find in the Unix ecosystem, right? So on a Mac and on a Linux machine, very Unixy. You'll notice that I'm just ignoring Windows because Nix doesn't work on Windows, even though Windows is also the Unixy heritage, and then it got weird. But package managers, in order to be able to manage this, they have to do a lot of bookkeeping. And then the shortcoming that you run into here is actually not so much in how we distribute stuff across folders, but how we assemble environments. Since our environments, like where we look for all of our C libraries, or where we look for all of our secure binaries, or where we look for all of our regular binaries, since they all come from roughly the same folders, then our environments, they get a little bit hard to namespace. That means that you can't install 2 different versions of MySQL, because now you're going to have 2 different binaries that have the same name, and they both can't go into user bin. So Nix fixes that by hashing every package, either the inputs or the actual content itself. And it's a lot like a container layer, right? Once we hash the package, we can store all of the things related to that package in one folder, and we'll put it into this thing called a Nix store. The packages are cleanly factored away from each other. And then the real trick comes into how to cleverly assemble these different folders into environments that work on a computer so that it feels like your normal style of development, where you can run a program and link into 5 different C libraries or something like that. Have some stuff on your path. And so dynamically managing the things that let programs find each other in a Unixy way, and let libraries link up into things, and let dynamically loaded things load into things. Managing the loader path is part of what Nix is really concerned with being clever about. And it gives you a lot of tools to be smart about that by having this functional programming language, which is notoriously hard to use. Right. And so Nix does more than just like manage packages. It gives you like this whole build system, and you can like configure your operating system with it if you use this distribution called NixOS. And you can manage your home directory if you use a community project, and you can manage your Mac if you use a different community project. And so it's really grown beyond just I need to hash libc. Now it's this fully declarative system for building reproducible distributed computing things. But it's hard to get into, and honestly pretty academic, and I will say the stack traces are super gnarly. That's why we are building Flox. Flox is aiming to make it easy for you to build these virtual environments that are tied to your project. And it uses Nix under the hood, but with an interface that isn't really scary for people who are just like getting out of code school, or who are a little bit more junior, or even all of you incredibly senior folks out there who just don't have any more time to learn one more thing, right? We want to be able to promise that when you install Flox on your system, which there's a macOS installer, you can get it from Brew as well. You just go to FloxDev website, then to our install docs. Yeah, apt. We have an RPM for it on Yum systems, and you can do a generic Nix install if you're already a Nix user. But we add some verbs, right? So we want to change the shape of the package manager a little bit. If you really think about it, computers, they used to be more for one thing and they had a long life cycle. Now our computers are meant for many things. Sometimes a server is hosting 10 different projects with some virtual hosting in front of it, or it's a node in a Kubernetes cluster that's running 40 containers. And that server has many jobs that need to be split up into different environments, but then it doesn't live very long as well. And on the other hand, like your laptop, you might have it for 3 to 5 years and you might work on 10 to 15 projects a year. And the package manager being built for one system and mutating your system globally, it doesn't really fit really well anymore with the things that we carry around in our backpacks. It doesn't really work for servers very well either, because now you can't install 2 different versions of a database or something. And so that's why containers have been the saving grace for everything. But containers are primarily a virtualization technology. It's not a distribution technology, and it certainly isn't a cross-platform technology, right? A Linux container is going to force you to use Linux as an abstraction anytime you want to use it anywhere. That becomes a little bit unfortunate when you have a very fancy $3,500 Apple Silicon MacBook, because that chip is really nice and has like a unified memory architecture that allows you to run programs on the GPU and do all kinds of fun stuff. And it's got like really fast access to memory and to the flash, where running a database on that thing actually makes a lot of sense. So why pretend like it's a Linux computer? Unfortunately, it's because it's the best option right now. How can we get beyond that? Let's just get into demos. I'll pop over here. Maybe do one more layout change. And let's go here. Cool. All right. We are at the happy place here. You can see that I've tried another take of this recording before, and I wasn't really that happy with it, so I'm doing this again. But here, if Flox is a package manager, we must be able to do package manager things, right? So let's Flox list. This is all of the packages that I have installed in my default environment. My default environment happens to live in my home directory. You can see here in my shell, I have a little integration that's just showing me where I am in my environments. So this is active, which means that I should be able to run htop. And I should be able to like Flox remove go. And then that should be fast. And now I don't have go from Flox. I actually do have go from a version manager. So this is coming from a gimme. Apparently it's Go 121.5, except I don't know why this is, but oh yeah, it is. Okay, yeah. But if I Flox install Go, get that back. And now I have a newer version of Go, maybe? Oh. This is actually unexpected. What did I do? Okay, so here, you guys get to see a little bit of debugging. I'm not sure why Go is not coming from the right place, because Flox should be higher in the path. You can also see brew is linked in something weird into my paths. You can see here my Flox environment has a .flox/run directory with my operating system and architecture. So this is AR64 Darwin, and then there's a bin directory. And presumably in here, there should be a Go binary. Yes. And that is the version of Go that I want. And presumably it should be the version that's getting executed too. But for whatever reason, the path search is not behaving the way I would expect. Okay, I don't know. Maybe it's something weird with Z shell. Anyway, but there you go. Go is installed, and I have a new version of it. I also have htop, right? And that is also coming from Flox, as is bat, and I think even my version of curl. Yep, might be coming directly from Flox, as maybe I don't have bash or anything in here, do I? Yeah, no, it's just mostly command line tools and then core utils. So maybe even, no, not sed, rock. These are still the Mac versions. Cool. Anyway, that's the default environment. This is all actually coming from a manifest, right? So I feel like I am actually removing these packages imperatively, but it's actually being done declaratively. And this is a really big idea here. We pretty much stole this directly from language package managers, which totally have this figured out. You can imagine that if there is a manifest that lists packages and other attributes about the environment, like I get define environment variables here and activation hook, which runs as a script in my shell of choice, profile hooks as well. I can also restrict my environment to particular systems and architectures. Like if I only want to run on Linux, then I could remove the Darwin systems from there. But that gets into a very important point. When I imperatively say flox install go, this is declaratively editing my manifest. And that manifest actually also immediately produces a flox env manifest lock. Right. And in here, it is that manifest file, but then all of the information that you need to get the exact bit for bit reproducible version of that package. And when I say that this package is reproducible, I don't just mean that it was built and that it's saved in a binary cache somewhere. I mean that somebody really smart wrote a Nix expression to make sure that this package, every time it's built, is bit for bit the same exact thing every time you build it. And that means that like the time by which the package like was built doesn't affect like the bits and the hash of it. And that is a pretty profound concept that lets us do some funky caching of builds later on in this story. Now, this is pretty boring, right? We're locking some packages, so this is good. Now we have a manifest and a lock file. So you can imagine we could check this into a repo. Let's go ahead and look at one. If I go into this Terraform repo, I have a log, and you can see I have a commit here that says add OpenTofu with Flox. Okay, let's go ahead and show that commit. And there's a lock file update. And then if I scroll all the way down, you can see the manifest update here. There is an install. It adds OpenTofu. The reason that there's a left hand and a right hand side of this is I could rename this and have multiple versions of this same package. You can also add version numbers right here. It's just like @ and then the version number. And then here in the hook section, anytime this environment is activated, then we'll run tofu init. So what does it mean to actually activate something? Let's try. Flox activate. So I'm in this folder, and then you'll see now it's actually run that tofu init for me. And then I'm inside of this environment as well as my default environment, right? So which htop is, oh my gosh, what is happening? What on earth is happening? I uninstalled that earlier. Yeah, that's why. I'm just going to flox install htop, and then I'm going to do that to a particular directory here. That'll immediately fix what I was not expecting there. Thanks for suffering through that moment of confusion. Cool. So I still have my default environment, right? It still works. And then I also have the tofu command line tool. Right, so here we can see that I'm OpenTofu 182 on Darwin ARM64, and I have a provider that has been downloaded for me as a result of activating this environment. I can exit, and then I can try to do the same exact thing, and it's not going to work. But notice, I'm just in subshells. I haven't been starting containers or anything like that, and all of these binaries are natively compiled for my architecture to fully utilize the entire address space of all of the flash memory or I should say all of the memory on the chip, as well as all of the flash storage available and all of the CPUs without relying on any sort of virtualization. It's just binaries. There's and just some environment variables and some clever mounting of read-only folders and stuff like that. So there's good isolation happening here, but this story is boring without also then going over to a Windows box. So let's go ahead and go to my ROG ally. I'm going to SSH in there and start a WSL environment. Let's go ahead and pop into a Flox activated ZSH here, go into our home directory. Try not to mistype too many things. You can see over here, I've got a little bit of a different list of things: durenv, git, GNU PG, pin entry for committing with some signatures, stuff like that. Let's go. I cloned this repo earlier over here and just tested that it worked. So I'm git show, same Flox environment, and I just Flox activate. And again, we are on the same OpenTofu version, but this time compiled natively for Linux, AMD 64. So different operating system, different architecture, and still getting that provider pulled down for me by Terraform's own built-in package management. Like, this is starting to build a really cool story. Now I have a simple way for me and my teammates to get to the same dependencies, and I can stack them on top of each other, right? If I hop back out to the Mac, let's get out of all these shells. And let's go over to an example environment. I have a Go application here. There's a little bit of source code here for a small HTTP server. What kinds of things would I need for this? So maybe I would want to build a Go application and then push it to Kubernetes and generate a deployment manifest for it, and then syntax highlight some of the things that come back from kubectl. And naturally, you're going to end up with a longer dependency list than this, but it's like a nice, simple example environment. And this would work perfectly on my Mac. It works great. You can just activate it, and I can put this, just git commit the Flox folder and push it, and somebody can pull it and activate, and it'll work on their machine or on a CI server or even in a systemd unit on a production web server. Totally would work just fine. The last environment that's just worth demoing here before I get to talking about moving forward beyond the workflow is, here's another kind of infrastructure-y environment. You'll notice here that since I have so many environments activated, Flox is really double checking that I know where I am. And here I've got Google Cloud SDK, Bitwarden CLI, and the Oracle Cloud CLI. Now, I can't tell you about the number of times that I've been frustrated with the Python that's been built into the Brew distributed Google Cloud SDK. It's just, because it's on the global path and like you have to modify your shell RC to do things with it. I've even had a lot of instances where like Google Cloud SDK itself breaks by having some strange Python issues that I don't understand. And then I just have to go and look it up and find somebody's comment on a GitHub issue to mutate the files on my file system to make it work so that I can log into a virtual machine or talk to a Kubernetes cluster. And so having this be just pulled from my binary cache and built by the community and validated in a reproducible, bit for bit reproducible way. I've uninstalled gcloud. I don't have it on my system anymore from Brew, and all of my problems are gone now because I can just activate in this environment. And the analogy in my head of what this feels like for me is, it feels like this whole time I'm usually just trying to crochet. Like, I'm usually just doing a little bit of fine electrical soldering. And then like right next to me in my garage on my workbench, there is a table saw and it is plugged in. And I am one moment away or one collaborator away from having an accident. Or just, it's just in my way. It's just a mess. And I'm tripping over the cord. And I just put the table saw away. So like right now, I'm actually, you can see that when I type a gcloud power level 10K, is noticing that it should probably tell me what environment I'm in. So I'm over here just in my main account, and I can just talk to the cloud and I can spend money now. And now I just type exit and I can no longer spend money, or at least I can no longer change the amount of money that I'm spending. So it's just a beautiful thing to be organized and to be able to put stuff away. Back to our, let's just go to, I don't know, the Go environment, right? We have a couple of commands that are a bit under construction. Right now, there is Flox build, and we have a little message, a little playful message here, but this is actually functional. It's got a help message, and you can pop some build commands into your manifest, and you can start wrapping your build in a way where the outputs will be shoved into a Nix store. The thing that we are working on here is to also give you a ladder so that you can take your impure software that relies on public sources and the internet and reaching out to all of the resources of your system, and then you can start to constrain it a little bit. Maybe turn the internet off, and then also not be able to access every single file path on the system. That would be good, because then you can start to reel in the clock and turn on all the build flags to make your build fully reproducible. How do we make that easy for you so that you can get the full power of Nix and then start having an incredible cache hit ratio inside of your build systems, to where like maybe your builds are 2 seconds? That would be awesome. And the other thing that we have going here is, if you actually, this is a public repo, env verba. This is also available on Flox Hub, which is a service we provide that you can just like Flox activate -r flox/verba to get to this. But I'm just going to activate here. And actually, I'm going to add the start services flag. Cool. I have a service running, and I'm just going to prepare going to localhost 8000. So you can see that I've got this retrieval augmented generation application. We have a stack of a couple of services running here. If you look at Flox Edit, Python 3, a Weaviate vector database, Ollama, which is in charge of pulling generative AI models for us locally, a couple of pre-printing things, make sure bash and curl are just pinned. This, I love this, because like this, you can actually write a bash script that will behave expectedly on somebody's machine, and you don't have to worry. And then same thing, like the version of curl on somebody's machine, like you can make sure that it has the HTTP2 protocol in it or something. You can pin like sed and awk and not use the BSD version of tar ever again, and it just makes your life better. But yeah, set some variables, hop into hooks over here. So you can see that we're starting to feel a little bit like Docker Compose, but just in a TOML format and with no containers. It's just going to run processes on your machine. In the services section here, start a vector database, start Ollama, conditionally wait if a certain environment variable is set. If not, just immediately start the Verba UI service for talking to the RAG application, and then also waiting for Ollama to be ready and then pulling some models into it. There's a couple long running services here, and then one kind of one-shot service. And you can see that we're intending to run this on ARM Macs and any Linux machine. So it's also a Python virtual environment being activated there. If I do Flox services status, you can see our models have completed, and we are running the VectorDB Ollama for our model execution, and then our front end. You can get the logs. So it feels a lot like Docker Compose, but with no containers. Here's what doesn't feel like Docker Compose. Let's open some other shells here. Let's make sure to just activate those. We don't have to start services again because Flox already knows that this environment is active. What Flox also knows is that if I close the first one and then I close the second one, the third one or whatever, like I'm still working on things. But that I just make just so I don't lose my window here. If I close the last active environment, the services will immediately go offline. So that's a really sweet feature, because now you don't have databases eating up your battery. It's just the benefit of working on a computer, like, and actually using it instead of pretending that it's a Linux virtual machine. All right. Here's the first bit that doesn't work on a Mac. Let's go to the FloxN for Go. And let's try to containerize it. We're done with our workflow. We want to get to the artifact part. It says error, containerize is only supported on Linux. So we're trying to fix this. It's probably going to require some sort of QEMU thing. But at some point, maybe when it's possible to execute Nix with Wasm or something, maybe that could be interesting. But for now, we'll probably need a Linux virtual machine or like some sort of path. You can always start your own VM. But I'm just going to SSH over back to my Windows machine. And let's pop back into C shell. Let's find. So I built this like little Flox environment, just initialized a Git repo in here. And I have a couple of dependencies, and I can containerize this. What this is doing is it's taking the environment that has been built with Nix, which let's see, I guess I can show that in a few seconds, but we inflate this all the way through. And that environment has a bunch of other dependencies in it. And it is putting each of those granular dependencies into a container layer. This is really awesome because container layers are already content addressed, and all Nix store paths are also content addressable inside of a binary cache. So you could get to a world where every single Nix package is stored inside of an OCI repository. And you could even have a pull-through cache that's like right next to your cluster that only pulls layers that are each individual packages, right? And we are trying to construct a perfectly efficient container image here that can be fully deduplicated in storage and then have the highest cache hit ratio possible, right? You're no longer having like multiple versions of bash stored across 30 different images. There's just the versions of bash in your registry, and your images link to the one that they want. And if you could get containerd to unpack these layers, just like any other container image, then it ends up in an overlay file system. And what's going on with this? So this is a little bit sad. Unfortunately, there is a layer limit with normal Docker containers. And it comes from the Linux kernel's inability to construct an overlay to file system with more than like 127 mount args. And so here we're capping at 99 just so that there's another 20 or 25 layers of space for you to stack on top of it before you're getting close to that layer limit. But once we get to the end, we have to heuristically pick a list of packages to combine into layers. And this completely messes up with the cache hit for all of these things because it will probably be a different list for different containers. So this is unfortunate. How do we fix this? The folks at PDT Partners have built a containerd snapshotter plugin that integrates directly with Nix. And I have a pretty bare bones NixOS configuration here, but if I go to Etsy, NixOS configuration.nix, you can see that I have added a Nix snapshotter import here. So this is Nix expressions in the Nix language. It looks sort of JSON-y, but then the stack traces are terrible. That's the difference. And yeah, we define an import for the Nix snapshotter project from PDT Partners. That's just on their GitHub. They have a great README. I pretty much just copy and pasted this right in from it into my NixOS config to just customize it. And you can enable the systemd unit from the NixOS package and module for containerd, and then use their module to patch Nix snapshotter on top of it and then enable it, right? So that's what's happening here. And the end result is that if I sudo nertctl info, then you'll see that in storage, containerd now supports native overlayfs and Nix. And what this means is that if we build a special OCI manifest that points to Nix store paths, that instead of containerd pulling layers from an OCI repository, it will talk to the Nix daemon, and the Nix daemon will pull just derivations like directly from whatever Nix store and whatever binary caches it can get to. And then it will fulfill like sort of its promise to containerd, and containerd will take that Nix store path and it will bind mount it into our container for us. And because bind mounts are a lot cheaper than overlays, the Linux will do lots and lots and lots and lots of them. I think that in the rough research that I did, recent Linux kernels have a limit of 100,000 bind mounts, which seems like it would be enough to maybe run 1,000 containers or something with 100 bind mounts of different packages, or maybe 100 containers with 1,000. The math seems to check out there, and that it might scalably be something interesting to do. Another idea that I had here is that maybe it might be possible to tombstone the Nix store somehow with an overlay in a creative way. I'm not sure fully if that would work yet because you would have to update the tombstones while the Nix store was being updated. And that could maybe get race conditioning. You wouldn't want store paths showing up in containers that were not supposed to be there. But there's a lot of opportunity here because you could potentially, deduplicate all of Docker Hub if we could just get the ecosystem to move towards a little bit more organized packaging. And you certainly could just very much deduplicate your own Elastic Container Registry account or reduce the number of hard drives that you have for your local harbor installation. There's a lot of opportunity here as cloud native. As far as building these images goes, so you actually need to read the README and then learn how to do Nix right now. And so there's opportunity for us as the Flox project to make it simpler for you to basically call this helper function that's included in the Nix snapshotter project. The schema is fairly simple, and then you can see here that the entry point is being set to a package that's coming from Nix expressions. That's how this Docker image is ultimately being constructed as a tarball and then exported from this flake. But in this example, and maybe there are some simpler interfaces that we can build to that in the future. The last thing that I would like to highlight here that really contextualizes going from artifact to runtime out of a changed habits of workflow by using Nixy tools to get cleaner dependencies that are factored for your system is that we could make Nix stores potentially fairly native to OCI repositories. And this is really attractive because if what is going into the container image are runtime dependencies that are actually factored as Nix packages, and those are the things that Containerd is actually reaching out for, and then we could potentially even teach Containerd to support non-conflicting layers because you don't need overlays. And maybe it wouldn't be fully dependent on Nix anymore, so there would be a non-conflicting layer snapshotter or something like that. That way you wouldn't have to have a Nix daemon everywhere. Then we could just throw Nix packages in an OCI registry, all of them even. And when you work on Nix stuff, Nix would know how to pull from the OCI registry. And when you are then building, you don't have to push anything back because it's already there in the OCI repo. So you just push a tagged manifest that references the things that you need. It's maybe a couple kilobytes. And then now your Kubernetes cluster, all 100 nodes or whatever, have immediate cache deduplicated access to those things. And you can start your containers instantly with no pull difference or anything. And then when you need to update a package, you change something in a Flox manifest, and it updates on all of your developer workstations, and CI automatically builds it, and then it just gets pushed out. And there are these very small layer differences. And you can see a world where the software supply chain is so much more maintainable. That could be a really cool place to get to. And maybe that would free us up for the cycles to actually pay all of the maintainers to keep the supply chain secure. And then we can trust the updates because we can install the proper social machinery to build a cleaner ecosystem instead of this sort of workaround that we've got into with Docker containers, where a virtualization technology has become a distribution and packaging format, but without the packaging discipline. I think that there's so much exciting opportunity here. Consider this a preview of some of the things that we are building and looking to talk about at KubeCon and at Rejects and coming into the later part of this year and into early next year. So we're building private catalogs. We're finishing up the pure builds portion of the Flox build experience, looking at export operations for containers and that kind of thing, and getting into the runtime. I'm trying to do my best to bring my Kubernetes context to all of my teammates who know so much about Nix, and I'm learning a lot. It's very humbling. But if you heard me if you heard me say anything spicy, anything that resonated with you, let's start a little bit of public discourse. I can't wait to field your questions. And there's so much to be excited about in this space. thanks for coming in and hearing about Flox a little bit. You can go to flox.dev and install and change your workflow. And hopefully those workflow changes will produce a little bit of ergonomic efficiency for your team and can produce habits that produce more cleanly factored dependencies for your artifacts, and that eventually paint a long-term story for changing the runtime and maybe even reinventing the container image format a little bit, getting past the layer limit. So thank you, friends, and I will see you on the internets and at the conferences.